What's good, my analysts? It's your boy, new location, same mediocre content. Got another PowerShell payload that we're going to take a look at today. This one came from one of the fellas. They found this on the engagement a while ago. He sent me a message asking if I could pull the data out of there, and then I honestly quite forgot about it. And then he started chirping me as they do, saying that I got soft and I could no longer do real work. And I appreciate his persistence because I came back and took a look at it, and it does have some cool things that we haven't covered before. And I'm also going to show you kind of a little bit of a shortcut on how to deal with some of these things to make it more efficient to go through. So let's go ahead and jump right into it. This should be a pretty quick one based on all the other ones that we've done before. If you haven't done these, all kind of build on each other. So if you haven't watched the other ones, I suggest you start at the beginning. Otherwise, let's just jump right in. Okay, so if you've ever watched any of my content before, you know that I've talked about this Windows event log 11 billion times. So this is Windows event log 7045. This is where they came across it. This is a new service that is installed. Adversaries and malware and everyone and the like. Evidence of their behaviors can be found in this all the time. So the first thing we want to do is take our big long string of gobbledygook here and make it a little bit more human readable. If it's on all one line, because in PowerShell it does that through using a semicolon as the command delimiter. Separator is probably the right word, but so you can put multiple PowerShell commands on a single line as long as you put a semicolon. And what we're going to do is basically just take and do a find and replace for all the semicolons and put a new line, so it's easier to read and we can kind of see what's going on here. So we're going to do that. Back, boom. You could do that all in PowerShell too, but it's honestly just a lot faster to use Notepad++. Okay, so what do we got going on here? First thing we see is doing some environmental checks. And then we have a keyword here, which is system.diagnostics.process.start.info, which tells us that they're going to use PowerShell to run another process. And that process is going to be PowerShell as defined above, and the arguments are a big old glob of gobbledygook. And on the bottom here, we just have the context in which it wants to execute and then actually executing, which is great because that means we can ignore everything except for the arguments, right? Because that's where all the good stuff is. The rest of it is just, hey, we're running a new process. So let's go ahead and copy pasta that out and take a look at it and see what we can't learn. Now, one of the things immediately that I notice here is you will see that there's a lot of escape characters in there because we got strings inside of strings, right? Right here's a good example right here, these two single quotes. And so if we copied and pasted everything out of, I'll show you, if we just copy paste that out, like we're going to get a bunch of errors here. And it's not going to be fun for anyone to look at that. It's so angry. So the first thing we want to do is go ahead and all we're going to do is a find and replace on two single quotes and replace that with just a single quote. We do that. Makes it a lot easier to read and a lot less angry on the screen. And we can see what's going on here. Okay, so we have two different pieces of this. It looks like it seems like right off the bat, I can see this right here, this ampersand. This in PowerShell is like an invoke expression. It's saying run whatever is after that. And in this case, it's a script block, another big old long line of Klingon we probably need to take a look at. The system.io.streamreader, we've seen that a million different times. That's probably where the base 64 blob is. And then the rest of this looks like it's doing some preparation before it launches. I can see here that we can, pretty easily determine that that's the word blocking. And so it's probably doing something to disable or check script block logging. Probably going to check or disable AMSI. But it is really hard to read, right? This is annoying, and you could go through and there's probably tools out there that will help you de-obfuscate this pretty easily. But I'm going to show you a quick trick. First thing is we want to make sure that we're gonna copy this out, but we want to make sure we just comment that out so we don't accidentally execute the payload on our system. And I'm gonna show you what I'm gonna do. So basically we have all of these different variables, right? And this is a common tactic used by obfuscation tools or obfuscators, is to take a bunch of stuff that's really hard to read that into a variable, and then do evaluations against those variables to get PowerShell to actually do something pretty standard or in the clear, and we just don't want, they want to hide it from us so we don't have an indicator to key off of for behavioral based or indicator based detections. So because they're all variables, we can use that to our advantage. And I'll show you what we did here. So we're going to basically copy all this out, except for this. We don't necessarily need that. You could just delete it. And I did that here. I said we didn't need it, but I put it in here and I just read it into a variable called X. And I did some, new lines and tabbed it out so we could see a little bit more clearly, but that's not necessary. And you can see, yes, it is. There's a lot of different variables being declared here by, trying to obfuscate what it's actually doing. And we can use PowerShell pretty easily to do this for us. So what I do here is you're going to use the compare object variable or function in PowerShell to basically evaluate all the new variables that were declared upon execution. So before any of this, PowerShell knows about any of this junk down here, we're going to grab all the variables that it knows about in the session, read that into default vars, then let PowerShell do its thing. And then after that, we're going to read another one and say, well, give me all the variables now afterwards. And then we do a compare object of what was before versus what's after and show me the differences. And we have our payload piece sitting there. And if we run this, we can quickly see that PowerShell will just show us all these variables, what they were set to after they've been de-obfuscated and evaluated. And that makes things a lot easier to see what's going on. What is it doing before it actually runs its payload? And you can expand these out further if you'd like to. You could read all the matches into a variable and really dig in if you want to. But as we thought, it's doing script block logging, probably disabling that. Yep. So trying to disable script block logging is doing something with AMSI before it actually runs this thing. So, okay. So now we understand what it's doing that. We can check some registry keys to see if it's been modified as a indicator. But let's go ahead and take a look at the big mamma jamma down here on the bottom. So we have seen this quite a bit. New object system.io stream reader and any of the other ones that we've used CyberChef to kind of go through. And so essentially this invoke script block is just saying evaluate this as a script block, run it all at once. So we can ignore all this and just copy what is in the parentheses out into a new variable. So we've done this before. So this is basically using new object, everything that we've seen before, all the different times that we have done this in CyberChef, it is the same thing. Now, the difference thing is if you took this from base64 string that we have done a million different times and copied that into CyberChef, not only is, well, it's going to say it's not valid base64. Not only is it doing a concatenation of strings here, so it's doing a plus. So it says it's not one big long string, it's a bunch of small ones put together, but will be valid base64. But you also see that we have these in here. These, brackets with a number in there, and those obviously aren't valid base64. And I'm going to show you how that works down the end here. Why that is. This -f. So this in PowerShell is the dash function parameter, and basically what that allows you to do is pass a array of values, which will then be evaluated against whatever string you use the format against. And I'll show you how that works right now. So let's say that we had something that we wanted to say test. This is a test, right? We wanted a test variable to read this is a test, right? But instead of doing this is a test, we do this is right. So these are basically array values. So these are value spots in the array. And if we read this out, you can say, yep, it has those in there. But if we go test-f and we put in this is A and test, this is in the 0 spot, this is in the 1 spot, this is in the 2 spot, and if we run that, we can say this is a test. And the same thing it's doing here. So it's doing a function, it's doing a format, and everything that is 0 right here are going to be replaced by equal signs, and then everything in 1 is going to be a B, and everything in the 0. And if you did that, if you did a find and replace plus concatenated all that, you could put that into CyberChef, and then it would evaluate it as valid base64. But that's also like very, very complicated, right? We can just use PowerShell to do that on its own. So if we do that, we just read it into there, just let PowerShell do its thing, because it's not doing any invocation there. All it's doing is reading it to the end, and it does the decompression for us. So if we do that, we're going to see that is a very common, that same second layer of obfuscation payload that we've seen a billion different times, right? Here we can see it looks like the don't kill my cat. And as we know from all the previous videos, all the goodness is going to be in that second stage of base64 data. Here's our byte array. We've gone through this a million different times. And I'll show you how we can use PowerShell to do kind of like what we've done before in CyberChef, right? So we know that we need to grab this little piece right here. And in CyberChef, what we did that is by doing a regular expression. We're going to do the same thing in PowerShell here. I'll comment that out so we don't have to grab it. And then I'm going to say, we know this from previous ones that this is shellcode. We're going to say, okay, we have S, which is the decompressed, de-obfuscated thing there. And we're going to match that against base64 pattern, and then show me the matches and read that into a variable called shellcode. So if we do that, we're going to get the base64 blob that we got, right? So that's very nice. So the next thing we want to do is actually read that out into, we got to do the from base64 in there and make it look actual shellcode so we can evaluate it. I'll show you what this looks like. We just read it out and you're going to get it. Here's our shellcodey thing that we have done a million different times. When we read that out to a file so we can use, so we save that off and we can go to scdbg and we're just going to point it towards that test.dat file that we just got from the PowerShell payload, run it, boom, it's opening up a socket. And then here we can see the instruction is to open port 12957, which, so this is going to be a bind port. So this PowerShell payload was going to be used for a bind shell at some point to establish on follow-on activity. So that's how you extract the tactical information from those kind of payloads, and using PowerShell to kind of shortcut and make things a lot easier to understand the context behind that. As always, happy hunting. I appreciate you being here. If you ever come across a payload that you're struggling with, shoot it my way. I'm more than happy to take